we're starting the metabolism section. So we did calories before, and those formulas were pretty simple. Let's multiply 3 things together, or let's multiply 2 things together. These formulas start getting a little more complicated because metabolism is a little bit more complicated. The first things we'll talk about are heart rate formulas. Your maximum safe heart rate goes down as you get older. Since the 1970s, the guideline was 220 minus your age, which is easy to do, but it's not terribly accurate. And as people have had better and better health, and as we're staying active longer in our lives, then more older people care about this kind of thing. There's now a better rule, which is you start at 211 and you take away 64% of your age. 64% of a number would use RIPLUP on the 64%, change it to 0.64, and then of means multiply. So we're doing times 0.64. And whatever we get from that multiplying, then we have to take it away from 211. These parentheses are a little suspicious. We know from the order of operations that multiplying happens before subtraction anyway. So these parentheses are just here to help our eye read the formula, to help sort of pace us or parse the formula. They're not needed if you plug things into the calculator. Then we have 2 other ones. Aerobic exercise is when you're burning more calories proportional to the intensity of your exercise. If you went up a little bit to the activity where you do jumping jacks or something, you can actually play around with that. So what counts as aerobic exercise? You have to get halfway, 0.5, up to your maximum safe heart rate. So first you find this answer, and then you do times 0.5. It's also true that when you're doing aerobic exercise, you don't want to push yourself too much. You don't want to get all the way up to your maximum safe heart rate, because then if it gets a little more strenuous, you're going to go to the hospital, right? So you only want to get 85%, 0.85 of your maximum. That is safe to be at for a long time. Okay, so nothing too hard. Formulas that are a little bit more complicated. We now have subtraction as well as multiplying, but this isn't too bad. So let's actually do an example problem. Take our formulas. That's kind of huge. So we have 3 steps. First, we have to find his maximum safe heart rate. So we'll take 211 and we'll subtract 0.64 times his age. Nothing else about this person matters. Doesn't matter how tall he is or how much he weighs or whether he's male or female. This is just a age-only formula. As before, as I mentioned, if I wanted to, I could put parentheses around here, but I don't need it. My calculator is going to multiply with priority anyway. So let's plug this in. So if I turn on my calculator, and I get 188.6. Now, just like those calorie formulas we looked at before, we don't actually know this to the 10th of a beat per minute. None of these formulas are that accurate. He hasn't weighed himself, or he's not exactly 35 years old. I don't know why I said weight. So let's round this and just say 189 beats per minute. Okay, next we have the lower limit for aerobic exercise. We're going to take that 189, multiply it 0.5, and we get about 95. Again, I'm rounding beats per minute. And then finally, we have the upper limit. We go back to the 189. We multiply it by 0.85. And we get about 161 beats per minute. Okay, questions on any of that?
Where did you get the 0.85 on the upper limit formula?
That's just part of the formula.
Oh, that is just part of the
Right?
formula. Okay.
Remember that this number here is
Oh, there
like
it is.
85%. So people decided 85% of your absolute maximum is what's safe to keep your heart at. If you're getting 90% of your maximum, you're kind of straining yourself. Might not be healthy. Yeah, maybe it helps me to highlight things. So there's the 0.5, and there's the 0.85. Should we do another one? Are we all set? We're good? Okay, I see thumbs up. Okay, those are pretty easy. The next ones get a little harder. Our body uses energy even when we're resting, just to keep our metabolism going. And that amount that we just need even when we're a couch potato is called the basal metabolic rate. Basal is a word similar to baseline. And the abbreviation is BMR for basal metabolic rate. If you visit your doctor's office, then you might see this kind of thing in the charts that they have for people. So if you were lying in a hospital bed all day and not moving, this would be how many calories you burn each day, just keeping your body going. And if that person who's a vegetable in behavior would eat more calories than that, then he or she would gain weight. And if the person ate fewer calories than that, then he or she would lose weight while lying there in the hospital. Now, we can't measure this well in class, but we can estimate it. A little bit of history. The name basal metabolic rate was invented in 1918. The two scientists were named Harris and Benedict, and they discovered that they could predict it by measuring the surface area of someone's skin. So imagine that you go to the doctor's office and they take out one of those sheets of little stickers and start putting stickers all over you and counting how many stickers it takes to completely cover your skin. And then they could figure out your basal metabolic rate. So no one does that. That's annoying. So they decided that they could make an estimate that's almost as good. Instead, that's a formula. It uses your weight, your height, your age, and your sex. So more complicated than the formulas we've seen before for calories and exercise, which only based on weight, or for heart rate, which is only based on age. So for more than 60 years, the Harris-Benedict BMR formulas were used. Now there's a more accurate set of formula. More research has happened. And here they are. There's two formulas. The woman's formula is this one. The man's formula is this one. They're almost the same. It's just that at the end, there's either a +5 or a -161. If you follow this link, you'll get to an article about how these formulas don't work on everyone equally well. We'll can talk more about that if you want. The formulas use weight measured in pounds and height measured in inches and age measured in years. If we were doing something with different units like kilograms and centimeters, we would need different formulas. But they're still formulas. We plug things in and we get on an answer. The calculator does all the work. Let's look at them a little bit before we do an example problem. Do they make sense? Does it make sense you would burn more calories if you weighed more? Yeah, if your body is bigger, it takes more energy to keep it going. Does it make sense that you would burn more calories if you're taller? Same thing, right? If there's more of you, it takes more energy to keep it going. Does it make sense that we're subtracting as we get older? Yeah, as we get older, our bodies slow down a bit. So, okay, this seems reasonable. So I'm going to grab these and put them on our board. And then grab an example problem. And I make that not wrap around. There we go. Oops. One last comment before we get going. Just like the parentheses before, these parentheses are not ones your calculator cares about. It's already true that we're going to multiply before we add or subtract. So these parentheses are just here to help you read in an intelligent way what's happening, to help your eyes follow the sentence. They're not actually needed in the calculator. Okay, so let's do this. So Arthur, which formula are we going to use for Arthur? That one, right? He's a man. So his BMR is his weight times 4.55, so 150 times 4.55. And then we're going to add his height. Now his height, it says 5 feet 8 inches tall. So we need this to be only in inches. What should we do?
Yeah, we just divide by 12.
Sort of. We have the 5 feet and the 8 inches. The 5 we multiply by 12, because each foot is 12 inches. And then the 8 inches that were not part of the 5 feet are just sort of hanging out on their own.
And then just add them. Yeah.
Yeah. Everyone okay with that? In some ways, that's the trickiest part of the whole problem. Okay, how old is he? 35. I'm running out of room, aren't I? Minus 161. Okay, squeeze it in. Okay, so I've set it up. Everyone okay with my plugging things in? Now the calculator gets to earn its keep. So 150 times 4.55 plus 68 times 15.88 minus 35 times 5 minus 161. So I'm getting 1,426 calories. And I'm going to round this. Just as before, these are only estimates. So I'm not going to say that I know it's 0.34 and some fraction of a calorie. Okay, while you're writing what I'm writing, I'm also going to make this look better for our people who aren't with us in person, that they can read this a little better after class. Okay, questions about Arthur?
Yeah, I was just wondering why for the height or why it's 15.88 and it's 5 feet and 8 inches, right? For the height.
Yeah, so the 5 feet becomes 60 inches because 5 times 12 is 60.
I
And
I
there's 8 more.
I like understand the steps, but I don't understand why it says 15.
Oh, the 15.88 is just from the equation.
Um,
It's basically saying every inch taller you are gives you another 15.88 calories per day.
oh, okay. Yeah, sorry.
Okay,
Yeah. I was looking at the wrong thing, I think.
that's okay. And I just said per day. I should probably be good about that. I mean, we can say calories, but this is really how many calories he is burning per day if he is a complete couch potato, not exercising at all. Okay, Odette's turn. Somebody lead me through this. Where do I start?
You multiply 110 and 4.55.
Okay. Actually, so I don't run out of room again. Okay, then what?
Plus, what does it say? 5-1
So we have to fuss
times.
again. So 5 foot,
Oh, yeah.
1 inches.
$61.
Yeah, so okay. Then we do the times 15.88. Okay, next.
30 times 5 minus 160.
Not minus 161. That part is for the men's BMR.
Oh, plus 5.
So she is up at this formula, so she gets a plus 5 at the end. Okay, everyone happy with our setup? So again, we're done. Now it's the calculator's turn. Do this with me. Make sure that your calculator works the same as mine. 1,324. Everyone get the same thing?
I did not. Let me punch it in again real quick, see what I missed.
Yeah, I think I've done it right. A common mistake is, since we're doing adding in the beginning, that we keep adding and don't do a minus there. Another common mistake is to mix up the end and use the ending for the wrong formula.
Oh, yep, there we go.
Okay,
I mispunched something.
it happened. It's a lot of punching, so. Okay, any questions on these before we move on to the next step? Okay, so this isn't too bad. We plug in things, but again, the calculator does all the work. We have a little bit to keep track of with feet and inches turning into only inches, but that's the only subtlety. So you can click here if you want. There's other BMR formulas if you had metric units and stuff. And there's some articles if you want to read. Young Hispanic women and Asian women tend to have different metabolisms enough that there's different formulas for them. But again, we're a math class, so we don't care if you memorize all the different formulas. You're not in medical school. We just want you to be able to do this. Okay, moving on. Fortunately, we are not couch potatoes all the time. The BMR is usually most of the energy we burn each day, but we get some extra bit from physical activity. And how much energy do we actually use during the day? It's going to be bigger than the BMR because we have exercise. It turns out the right thing to do is just take your BMR and multiply it by something. Multiplying by a number bigger than 1 gives us an answer that's bigger than we had before. And the World Health Organization has decided that for this accuracy that we have here, which isn't terribly high, we'll just categorize people into 3 categories. Are you a minimal exercise person, almost a couch potato? Are you a moderate, normal person? Or are you very active? You actually have exercise routines you do almost every day. And based on which category you put yourself in, then you get your number. So if you are a woman that does a normal amount of exercise, then 1.64 is the number you multiply your BMR by. If you're a man that barely gets off the couch, you'll use 1.55 for your number there. We can think about your daily caloric intake, the DCI formula, as how many calories you would eat each day to maintain your current weight. If you eat more than that, you gain weight. If you eat less, you lose weight. I should also be a little complete and say, by the way, these are not for professional athletes. If you do that much exercise, it changes your metabolism in a very big way. You may have heard stories of marathon runners that can't get pregnant because their body is just changed that much. So this is very active means I'm athletic for kind of a normal person. I am not a professional athlete. So let's finish things up. We'll grab these scale factors. We'll take the formula, what little there is of it. And we're asked about Arthur and Odette. Okay, so back to Arthur. You may have wondered, why did it tell us before he is moderately active? That wasn't part of our BMR formula. But now we care. So he is a man who's moderately active. So he is in the man who's moderately active. He's kind of a normal person. There we go. Odette, we saw, was very active. Again, that wasn't part of this problem yet, but now it will be. So she's in the very active woman. Everyone okay with picking out which numbers to use? So Arthur was 1426. We multiply it by that 1.78. And probably we'll round again. 2,538. Odette, her BMR was 1324. We multiply hers by 1.82. And she is at 2,410. Questions about that page? So lots of steps, but no individual step is that bad. So this is one reason why group work is great, and we have a study session before every class. If you need me to schedule other ones, let me know. Working together, it's really easy to say, wait, my answers don't match. I must have hit something wrong on the calculator, because that happens all the time. Working by yourself, you might not notice when you hit something wrong on the calculator, and it's a lot more frustrating. Okay, moving on. We should also talk a little bit more about realistic things. Again, it's not my job to be a personal trainer, but since we're talking about these things, I want to be a little responsible. There's a myth that exercising more leads to weight loss, but that happens very infrequently. Almost everyone, if you do more exercise, you eat more, and it kind of balances out. So you need to change both exercise and diet if you're trying to lose weight. There's also a myth in certain weightlifting circles that if you do strenuous exercise, your whole metabolism will get this boost for hours, and you will lose weight just because your metabolic rate goes up. And for most people, that's not true. If you go to the gym and pump iron a lot, yes, that activity burns calories, but your metabolism goes back to its normal state when the exercise is done. However, if you are older than 50 and you do both resistance exercise, weightlifting, and aerobic exercise, then your BMR does go up. Their metabolism kind of doesn't suffer the decaying with age that the formula showed us. So they can have as much as 30% higher BMR because they do both kinds of exercise. So if you have older relatives that only do one kind of exercise, you might encourage them to do both and stay healthier. Okay, so those are good formulas. You're going to see the DCI if you go to the doctor's office and pay attention to the screens. It's an example of how all the math we do in this class is both real and fake at the same time. It's real because this is an important formula that people use and determines things like your insurance coverage. And it's fake because no one, when they're working in the doctor's office, has to pull out a calculator and find the BMR or DCI by hand. They just put in the numbers and the computer gives them the answer. But whatever math you do need to do, why is that there? Whatever math you do need to do by hand, won't be any worse than this. So you'll need to do some math on the job. And if you can do this stuff, then you can do whatever you do have to do. So we might as well have you sort of jump through hoops and prove you can make the calculator do what you want on the stuff that the computers would do for you if you're a nurse or a doctor. So you understand the computers as well as sort of proving your worth. So there we go. Okay, here's some other ones you'll see at the doctor's office that we don't care about as much, and we'll talk about why. The BMR and DCI are both personal measurements. They were invented to measure how one person's body behaves. And they're not completely accurate, but at least we're using them the way they were intended. Your body mass index, or BMI, is a different sort of creature. It is your weight divided by 2.2. You also get your height divided by 39.37. First, you square your height, and then you do the division. So whoever developed BMI didn't intend it to be about individuals. They designed it as a tool to measure statistical differences in groups of people. It's a group measurement. It ignores how much of your body weight is muscle or fat. It ignores whether you're apple-shaped or pear-shaped. And even the government admits that BMI isn't diagnostic of body fatness or health of an individual. But a lot of doctors and a lot of insurance providers do say, have a healthy BMI, have your number be between this. So it is not supposed to be used to determine if one person is healthy, but people do it that way anyway. So you should just know that about the BMI. One thing that is a little more responsible is to see if there's a change in your BMI. Even though you can be healthy with a higher BMI just because you have a lot of weight from muscle, if your BMI changes, then that might be some sort of wake-up call. My diet or my exercise or something about me has changed. Maybe I even got some medical condition because my BMI has changed a whole lot since last year. So just because your doctor writes down your BMI doesn't mean they're doing things wrong. They could be checking for changes as well. So we're not going to do that. We don't really care. Another number you'll see is percent body fat. And insurance companies care about that. There's measurements that can be done. And a chart like this is basically all people need. You can just look at your abs and see, can I see my abs or am I just kind of squishy? The percent body fat people have is very difficult to measure accurately. Even 4% requires going to the doctors, and then they have calipers, if you know what those are, little metal pincher things, and they have to measure you all over. If you want a very accurate measurement, you have to have a fancy room and they put you in a tank with water and so on, and it's kind of annoying. Anyway, so don't worry too much about your percent body fat. More practical advice is the saying, nothing tastes as good as feeling fit. Hopefully that saying is true for you. And that's the end of metabolism. So we have 10 exercises as always. We have random exercises as always. Let me look again at the study skills and talk about homework a little more. If you read earlier in the study skills, it talks about how learning works. I'd mentioned the book Grasp last time and fixed the link to it. When we're done with class, first you want to go back and read the notes. So say, okay, let's go back to the top of health decisions, start at metabolism, and try the example problems. See if you can do them yourself and either peek at the answer or go to the Jamboard to see the slides we did together. Can you replicate what we did in class? Next, invent some of your own homework problems. So say, what is my BMR or DCI? Or someone else at home or whatever. See if you do that and if your answer makes sense. Then try the homework exercises, but it's best to not yet repeat the same type of problem a lot. Your brain will learn more if you start not at the random ones that are so repetitive, but at the ones that vary a little bit. A good reason, again, to work with people is that you don't have answers for these. So checking that you and someone else in the study session got the same answers is really helpful. As you're trying homework, look at your notes. If you need a certain example problem, if you need to explain something a little better, then make your notes nice. All of the tests we do in this class, you can use your notes. So if you show up for the final and you have 50 pages that are all a mishmash of stuff, then you're going to spend all your time trying to flip around and get to the right page and have a miserable final exam. If your notes are nice and lean, you have maybe 3 to 5 pages with some good example problems for everything, and you can turn to write what you want quickly, then your notes will be helpful and you'll have a much nicer time on your final. So use your homework as a test for how your notes are doing. Once you've sort of feeling like you have a handle on it, then use the repetition. Then go to the random problems and try them and see if you get them right and so on. And then finally, if you, as you're like icing on the cake, try to explain something to somebody else. It's a good thing to do either during class, if you want to take over, you can, or in the study session, or even just at home. And if all you have at home is a stuffed animal, then that's still better to try talking out loud to the mirror or the stuffed animal rather than skipping this stage entirely, because your brain does stuff when you try and fit things to words out loud. Turning in the homework, it's part of the grade because you're in a class. I have to make you turn in the homework. So there we go. Okay, as I mentioned before, homework will be due 2 class days after the last day people ask questions about it. So the homework for metabolism has no due date because we just finished metabolism now. The homework for calories has no due date because Akame asked questions about it before class today. So yay for her, no due date yet. If on Friday, no one has any more questions about calories, then 2 class days from Friday, so Tuesday of next week, calories will finally be due. But maybe we'll have some more questions on calories on Friday. Okay, I've talked a whole lot. Your turn. Any questions on things? Do you want to start another section? Do you want to do some review of how formulas work and order of operations? Do you want just to work on problems together for another 10 minutes?
On this the body mass index, the exercises, I was trying to see if I could find what am I trying to say? Oh, the I'm an answer key to it to double check the numbers that I have here.
Yeah, there's no answer key for the 10 exercises.
Okay, I
on
didn't
purpose.
think so.
So as I mentioned, if you went through and tried to redo all of the review problems, sample problems we just did in class, then by the time you get to the 10 exercises, you should feel confident. If not, do some random ones and see how they are. Which one did you try? We should all try it then and see if we get the same answer.
It was just the first one.
Okay, let me grab that and put it on the board. So that one needs the heart rate ones. Oops, passed it. There we go.
Let's see. I think, well, maybe it wasn't the first one. What did I? Oh, I'm trying to scroll back to the exercises.
Okay.
Okay, yeah, no, that was the right. Yeah, that's the right one.
Okay, eventually at number 6, we have to find for BMR and DCI. We can certainly all do that one too if you want. But let's start with the first one. You want to show us what you wrote?
No, now I think I'm realizing, are we on, let's see. No, that's the random exercises. I think I did somehow find a random one, actually, that,
Okay, well, let's do that then. Not a problem. So random one about Frank? Or...
I'm trying to think. Yeah, whoever it was weighs 120 pounds.
Okay, well, the problem with the random ones is I'd have to reload a whole lot to try and get
Yeah,
the
no,
numbers.
I must have,
But we can do random A if you want.
yeah, we'll go ahead and do Frank.
Okay. Okay, goodbye, Caroline, for now. Maybe we'll do those during the study session on Friday. Okay. Someone want to lead me through it, or do you want me just to go through it?
Is my mic on? Yeah, it's still on. Okay. Oh, well, it looks like I have Frank, but what am I calculating here? What is, oh, I have re-put in Frank's BMR,
Mm-hmm.
but you have that one right up there. So let's see. So start out with weight, 108 pounds. Times 4.55. And Frank's height is 4'9". Frank is not very tall at all. So 4 feet times 12 inches is 48 plus 9 inches. We have 57 inches times 15.88. Okay, and then Frank's age times 5, 37 years old.
Okay.
And then add 5. All right, looks like we're set up to punch it in.
Okay, not quite. You never told me what's happening with the arithmetic sign here, the age and the times 5.
Oh, yeah, we will be, yeah, it's the weight plus height minus age.
Yeah, this one's a minus, make that look like a multiply. And then you said a plus 5, but he's using the men's formula, so he's at a minus 160.
Oh, minus 166. Yeah.
161.
Yeah, sorry, my Zoom is all screened down to see the Math ORE website. Minus 161. Okay.
And my calculator pressing, if I did this right, gives me 1,051 about. Is that what everyone else gets?
7. Yep. That is what I got. Awesome.
I keep getting 1,198, but maybe I'm doing it a different way.
So it could be my fault. Sometimes my multiplying looks like decimal points. That's a times, that's a times, that's a times. Don't do 37.5.
Oh, okay. Wait. Okay. Then
Is your calculator happy, Roscoe? Okay. I am going to put a box around this and keep going. So that's the one part. And then his DCI. How do I get to the DCI?
the BMR times his active level, right?
Yeah, so we have to read he's a very active man. So he's going to be in the 2.1 category. Oh, Okay. And did you get your calculator wrangling successful with the BMR Acme? Am I saying your name right?
All right, I think I got a number here.
Okay. And these do have answers. So we can always say, show me the answers, 1051, 2207. Yay, we got it. Okay, anything else before we're done?
No.
No? Okay, let's do a little heads up next time. So we have food preparation, how to prepare a meal for a huge number of people, scaling things appropriately. We want to buy enough, especially produce, that we don't run out of stuff while we're cooking. And then we had the patterns we skipped, so someday we'll go back. When we're all done with that, then you can try taking a practice test for the health decisions, which is nothing more than the random problems for each section all put together. I think it is true that Jeff, let me stop the